Alright, so year 10. So this is third lesson on polynomials. So this lesson we are going to learn how to find values of a polynomial, and we are going to introduce another way to determine the remainder, which is called the remainder theorem. Okay, first let's have a look what do we mean by values of a polynomial. So sometimes we could consider polynomial as a function. Possibly some of you haven't learned what is a function. Simply speaking, function is just a notation, like you could write px equals a polynomial. Alright? And that notation px means if you put anything into that x, you are going to substitute the same number into the x on the right hand side. So that's what we call a function notation. Alright, so we are not going into the detail of function notation. It's just a very brief introduction. For the value of the polynomial, let me give you an example. If I have a polynomial px equals 2x cubed minus x squared plus 4x minus 6. Okay, how about I'm going to find the value of polynomial at x equals 1. So I'm going to substitute that x equals 1 into the polynomial. To do that, that's a notation. I write p bracket 1. So you see I changed that x into 1. Then on the right hand side, you are going to do the same thing by replacing that x by 1. Alright? And then you just proceed with the calculation and you will get the answer. Okay, so if we have p1 equals minus 3, then we call p1 the value of the polynomial, which is 3 at x equals 1. That's what we call value of the polynomial. The simplest idea would be just like you put the numbers into x, because x is a variable, and for a variable we could substitute different values into variable to have different outcomes. Okay, let's use the same polynomial to do a little bit more. For example, we are going to do p bracket minus 1. Okay, for p bracket minus 1, that's for us to find the value of the polynomial at x equals minus 1. Okay, so I'm going to write p bracket minus 1. Then I'm going to put that minus 1 into x on the right hand side. Okay, so be careful about your notation. Okay, when you write minus 1 3 to the power 3, is that good enough? Possibly not. You better put a bracket, because that number is a negative number. It's unlike a positive number. If that's a positive number, you could just write 1 to the power 3. But for a negative number, it would be much better if you add a pair of brackets on it. So the next move would be minus 1 within the bracket with square plus 4 times minus 1. Okay, you see I use a bracket for every minus 1 because that's a negative number. Okay, you could reduce the chance of getting confusion. 2 times minus 1 to power 3, we all know that's minus 1 times power 3 is minus 1, right? Okay, so 2 times minus 1 will be minus 2. How about minus 1 square, which should be 1, and you've got minus outside, so it's 1. 4 times minus 1, minus 4, minus 6. Alright, so what would be the answer? So the answer would be minus 13. Okay. How about 0? Okay, for the same polynomial at x equals 0, you just substitute that 0 into x on the right hand side. That's what I'm doing. This time I'm not going to add a bracket on it because this number is not a negative number. So since the number is 0, so all the terms, all the first three terms are all 0, and the answer would be just minus 6. Okay, that's what we call values of a polynomial. Okay, so all you need to do is to substitute the number into x and get the value. Okay, let's have more practice. For the first one, you are going to do what we call px. Okay, and you are going to find p2. Okay, so you are given a polynomial px and you are going to find p2. That means we are going to substitute that 2 into the bracket, into the x on the right hand side. Okay, so all you need to do is to do this. Okay, of course you might use your calculator to help. That's 22. Okay, let me do another one here. Okay, for minus number, need to be careful. Okay, you better write that's minus 1 with a bracket and square. So what you're going to have is 4. Oh, good. And C. Okay, so for C and D, okay, may I ask you to pause the video now and try to do it by yourself first and get the answer, and then track the answer with mine just a minute later. Okay? Alright. Let's track the answer, right? Make sure for negative 2, when you substitute negative 2, you have a pair of brackets for it. And when you consider the power, try to consider the minus sign as well. For example, minus 2 square should be 4. It's not minus 4, okay? Because minus 2 square means minus 2 times minus 2. That means 4. Because two negative numbers times together becomes positive. Okay? And when it's minus 2 to the power 3, it should be minus 8. Because you got 3 minus number times together. When two negative number times together becomes positive, you times another negative number, it becomes negative again. Okay, so need to be very careful about the sign of the numbers in this substitution. Okay, so for the fraction you are going to do the same, but possibly you might need your calculator to help. Okay, so let me show you a very interesting fact for all the substitution here. Okay, so now we know for the first question for A, if I substitute 2 into the bracket, into x, sorry, I should say, you will have 22. Okay, so actually that question is the same as the one we've done before. Okay, still remember this is our quick notes for our long division. Okay, so you see the same question. Okay, so when we use that's 2x squared plus 4x. Oh, sorry, not this one. Possibly I should. Okay, so should be this one, sorry. When we use 6x squared plus 2x minus 6 divided by x minus 2. Okay, so is this question quite similar to the one here? Okay, let me just copy it. Okay, and paste here for you to have a comparison. So you see, it's the same polynomial, 6x squared plus 2x minus 6. Alright, then in the last long division, the long division we learned last time, you've got a remainder which is 22. Okay, so now you substitute 2 into x, what do you get? You got 22 again. Okay. Alright, so you got 22 again. Okay, so what does it mean? Okay, so instead of doing all the long division, I get the remainder. Possibly I just substitute 2 into x, then I'm going to get the same value as the remainder. So what's so special about this 2? So the 2 here actually will make, when you consider 2 here, okay, when you put that 2 into the divisor, so divisor x minus 2, you see actually that will make that divisor become 0. 2 minus 2, 0. Okay, would that be just a coincidence? Would that be just a coincidence? That means possibly this time we just got lucky to have the same value in remainder. How about the next one? Okay, so the next one, 5x squared minus 3x minus 4, okay, divided by x plus 1. What's the remainder? So remainder is here, 4. Okay, so let's see what happens for our second question here. So B, so question B is like this. So for question B, I'm asking you to put minus 1 into x. Okay, then what answer do we get from that? Okay, what answer do we get? Okay, we get 4. Alright, so let's put 4 here. Okay, so if I put minus 1 into x for this polynomial, the value of polynomial is 4. Okay, are they the same? Yes, they are the same. Okay, so instead of doing all the long divisions, if you just want to find the remainder, you could just put minus 1 into polynomial. So what is so special about this minus 1? Okay, look, if I put that minus 1 into the divisor, what happens? So, okay, it will make the divisor 0 because minus 1 plus 1 becomes 0. Okay, so that's the second time we just put a number which make divisor 0 into x, then you will have the remainder of that long division. Okay, is that really a coincidence? Possibly not. Okay, possibly not. Okay, So try to have another look. So we got qubit polynomial C and D. Okay, so for C, you've got that px equal to x cubed, something like this, divided, and then you are going to do p minus 2, right? Okay, so let's see this question. Actually, we've done that question before. Okay, not this one, but here. All right, okay, so do you see that? Okay, I just put the question here. You see? The polynomial is the same as that 3a. Okay, and then we are going to find p minus 2. Okay, and the value of that p minus 2, okay, is minus 34. Okay, so do you know where is that minus 34 in the last notes? Okay, so you see that's minus 34 just here. Can you see that? Just the remainder outside. So again, we could see if you substitute a number into the polynomial, okay, so that number must be quite special. That number must be able to make that divisor 0, because that divisor is x plus 2. So if you put minus into x, divisor becomes 0. Okay, and if you put that minus 2 into the polynomial, what do you get? You get a remainder again. You get the remainder again. Okay, so it looks like really interesting. Even the last one, okay, the last one, the remainder is a fraction minus 13 divided by 2. Okay, and the polynomial is a cubic polynomial again, and the divisor 2x minus 1. Okay, so do we have so what do we do for this one? Okay, so that's our part D, which we have just finished. Okay, let's go to see here. Okay, so that's our part D. Okay, so when you compare that part D we've just finished with the question, the long division we've done last time. Okay, it's the same polynomial, right? And then divided by 2x minus 1. For that divisor, what number will make this divisor 0? Of course, the 1/2. If we put 1/2 into x, it becomes 0. So if we put that 1/2 into the polynomial, what do we get? Okay, so for our previous work, we know it should be minus 13 divided by 2. Okay, okay, so no surprising, you see the remainder again here is minus 13 divided by 2. So we've got 4 examples. So you will see actually the action of substituting a number into the polynomial has something to do with the remainder. Okay, so that's what we call the remainder theorem. Okay, oh sorry, here, oh sorry, should be here, sorry. Okay, so that's what we call the remainder theorem. Okay, so that's a very important theorem. Okay, so this is the remainder theorem. Okay, it simply says that if px divided by x minus a, divided by means division, so when px is divided by x minus a, the remainder is pa. Okay, so how that a comes from here. So a is something that's when you substitute that a into the divisor, you will make divisor 0. Okay, all right. So possibly let me have a break here. Okay, so you need to think about this. Give yourself 1 minute or so to think about it. Okay, so this is what we call the remainder theorem. Okay, so to find the remainder, you don't need to do the long division like this one. Okay, so this is a long division for a polynomial by x minus 3. Okay, so let me remind you, the things here is what we call px, which is a dividend, and the things here, which is called a divisor. Okay, so what would be the magic number for us to do the substitution? Okay, remember the number should be the one which could make divisor 0. Okay, so what number when you put into the divisor will make that x minus 3 0? Let's think. So if x minus 3 0, that means x equals to 3. So that's 3 is the magic number that we are going to use. Okay, so let's say consider that x cubed plus x squared minus 13x plus 10 divided by x minus 3, and we are going to find P3 because 3 can make that divisor 0. So we substitute that 3 into the polynomial, and you will have do the substitution. Then what number do you get? You could use your calculator to check, but that will definitely be 16. So what's so special about that 16? That 16 is just a remainder. Okay, so let's have a overview for the whole picture. So if something is divided by x minus 3, if you do the long division, you will get remainder 16. If you don't want to do the remainder, a much quicker shortcut would be just substitute that 3 into the polynomial, and you will get a number which that number would be equal to the remainder. Okay, so that's what you need to understand. Alright, so in conclusion, there are two ways to find the remainder of px divided by linear factor. Okay, so there are two ways. Which two ways? The first way, of course, is the long division. The long division of polynomials. Okay, the long division means the whole process. Okay, it's very tedious process we've learned last time, and our remainder theorem. Okay, and the difference between two things is, for the remainder theorem, not only it is much slower, much tedious, so very tedious, and time consuming, of course, very tedious, but it gives us both quotient and remainder. Okay, so what do we mean by quotient? Quotient is, okay, the expression on top of the division. That's x squared plus 5x plus 2. Sometimes we do need that quotient, right? So long division is very slow, very tedious, time consuming, okay, but it can give us both quotient and remainder in the end. Okay, for the remainder theorem, we have just learned much quicker, easier, of course, much quicker, but only gives what? Remainder. So that's why it is called remainder theorem. It only gives us remainder. Okay, good. So I try to relate what we are learning to our previous knowledge, which is the long division. You see the relationship between the two things, right? Okay, so let's move on to have some exercise. Okay, so when the question is just about finding the remainders, okay, using the remainder theorem, well, sometimes the question will ask you to find the remainder without long division. Okay, so there are two ways to do it. One way is just asking you to use remainder theorem, then you don't have a choice. You can't use long division, can you? All right. The other ways, they might ask you find the remainder without doing long division. Sorry. Of polynomials. Also. All right. Okay. Okay. Right. So let's first identify which is which. When they give you a polynomial divided by another polynomial, the first one will be our dividend. Let's say it's px. The second one will be our divisor. Okay. So what number are you going to put into the remainder? What number are you going to put into the x of that polynomial? It depends on what number could make that divisor 0. So first you need to consider when divisor equal to 0, then that x will be -1. So that x, that's the magic number. That's a magic number for the remainder theorem. Okay, so the remainder for the polynomial divided by x plus 1 will be p at -1. Okay, so all you need to do is to substitute that -1 into the polynomial. Okay. Okay, remember that's minus number. Okay, all good. And so that will like -8. All right, so that's the first one. Okay, how about the second one? Sorry, possibly I need to create a little bit more space for my working. Okay, so how about the second one? Okay, so for the second one, our px, first you need to find the value of x. Okay, x equals 2. Then the remainder will be p2. 3 times 2 square plus 2 times 2 minus 4. Okay, so that will give you 12. Okay, so that means the remainder will be 12. Okay, and right. How about for C, D, E? Can you do it by yourself now? And I'm going to give you some time to check the answer later on, right? Okay, please just pause the video now. Try to do C, D, E, alright? Alright, here are the answers for C, D, and part E. And you are going to do the same thing by substitute the number which makes divisor 0. So first find the value for x, and then substitute that number into polynomial. Okay. Okay, so let's see a rather challenging one. So this is f. Okay, for f, you see that's 2x minus 1 as divisor. So to find the value that will make divisor 0, you need to put 2x minus 1 equals 0. Okay, so the next step will be 2x equals 1. If you put that 1 to the right hand side, then x equals 1/2. Okay, so that basically the way to find the x for the remainder theorem. Okay, so now x equals to 1/2. Then you are going to substitute that 1/2 into x. Right. Alright. Okay. So plus 1. Okay. Of course, here you might use your calculator to help you if you want. Okay. So the first number is 1/2. Okay. The second number is 3 minus 3. The third number is 4. And that's plus 1. Okay. So what do we get from this? Okay. So that's basically you will have there are two ways to do it. You might have this one, or you might use decimal number as minus 6.5. Both are okay. All good? Right, so G would be very simple. All you need to do is see that x minus 1 is 0, x will be 1, and you just put 1 into the polynomial, and you will get the answer, right? You will be 1 minus 2 plus 6 minus 4. Okay, so that will be 1. Okay, and the last one, okay, let me give you some time to try, okay? Okay? Okay, the answer here will be 10, okay? So the x, you are going to do the substitution, should be x equals minus 1/3, okay? Because for the divisor equals 0, you make 3x plus 1 equals 0, and then x will be minus 1/3, okay? That's no problem at all. Okay, let's move on. Okay. So for example 3, the questions become a bit trickier. Okay. So again, you are given a polynomial in terms of cubic polynomial. Then it's divided by x minus 1. But this time, you are not going to find the remainder. Remainder is given. So they give you the remainder as 5 when that's px is divided by x minus 1. Okay, so again, when it's called when it's said the polynomial is divided by x minus 1, then this x minus 1 is actually what we call the divisor. Okay, and so the remainder is given. So what are we looking for? You are looking for that's k, because that's unknown k in the polynomial. So that's the something in the printing. Okay, so k is the coefficient of x. So you are going to find that's k. Okay, how could we do that? We could still use our remainder theorem. Okay, that's right. Okay, so consider the divisor equals 0. When divisor equals 0, that means x equals 1. Okay, then by the remainder theorem, we understand that remainder will equal P1. When you substitute that's 1 into polynomial, it becomes remainder. But the remainder is given as 5. So it's 5 equals P1. So what do we mean by P1? P1 means you substitute that 1 into x. Okay, there's the square. So k is unknown, but we know we could substitute x as 1. Okay, remember now you are going to find k, right? And so that's 1 plus 2 minus 2, that's 1. K times 1 is k. Alright, so how could we find k? So just take 1 to this side, and k would be 4. Alright, so that's done. All good? So that's one of the question. And okay, again here please check that it should be x squared, not just x. Okay, this time we have another one. This time you have x cubed plus kx squared plus 3x plus 4 divided by x plus 2, and the remainder is minus 4. So this minus 4 is remainder, and this is what we call divisor, and px of course dividend. Right, so again you need to use the remainder theorem. You need to substitute that the number which make divisor 0, and then you substitute that number into px, and which equals minus 4, and then you have a chance to find the value of k. Okay, so let me give you some time to work on it. Okay, so here's the way. First you need to find the value for x. Okay, so you make x plus 2 equals 0, then x equal to minus 2, and you substitute that's minus 2 into the x, and you solve the and apply the remainder theorem. We know that's r, the remainder, equals minus 4 as a given, and you substitute minus 2 into the x, and you got the values. Okay, so k is a fraction 3/2. All good? Okay, coming to the practice. So here are some practice for you. The first question is about the values of polynomials, and the second question is about the remainder. So you need to put different values into the polynomial. All right, and then you need to check, do we have the same polynomial? Okay, so do we have the remainder for each substitution? Okay, and we have some practices, some more questions for you to do the remainder theorem. Okay, and remember, the main idea for this lesson is about how to find the remainder without doing the long division. Okay, we can cut short our process to find the remainder by just substitute a number into the polynomial. Okay, and then you will get the remainder. But what number are you going to substitute in depends on your divisor. So remember that number has to make divisor 0 first, and then you substitute that number into polynomial, you will get the remainder. Okay, so try to do as much practice as possible and send your homework to me. Okay, so see you next time. Take care.